Alright, let's get this thing underway. Let's get some things built. It's getting late. Actually, it's not even late. I'm on earlier than usual, but I'm already feeling quite exhausted. So the circuit boards arrived today for the new USB-C meters. So it's nice black looking ones. And the new aluminium LED light rings, complete with the built-on what do you call it, DC jack and everything else. So we're going to go for this one first because that one there's going to require a lot of programming, but this one here I can test initially without even having to do any programming. So given my state of head, I am going to go with that one first. Now I'm just going to find all the other required parts. Eeny, meeny, miny, mo. Guess I can't find my parts. And also this will be powered using a 24 volt plug pack. So, okay, parts, where are you, parts? And I'll also get the schematic and board layout for it. Well, we'll just zoom out a little bit. It's a little bit squished in there. We didn't need any long locks. Okay, they're the push buttons that are actually a bit harder to push. Okay, that's our current driver. These are our side push buttons, so we're going to try those ones first. These are our current limiting resistors. That's the tiny 212s. It's a DC jack. What do we got here? There's tiny 414s, and we need these. These are the regulators for this. There we go. Might just put them into a container. Actually, no, can't put them in that box. Find another box, Paul. Nope, can't use that box, it's got stuff in it. Those are very standard 7805 regulators. Now you may be thinking, why the hell would anyone use a standard 7805 in this day and age? And it's because the 7805, the standard one, is very good at handling high voltage drops. So we're going from 24 volts and we're dropping down to 3.5 volts actually in this case. And so obviously that's a pretty big jump, and a lot of what do you guess? I think I might just leave these in the bags. And a lot of regulators don't quite appreciate a 20 volt plus difference between the input and output. LEDs, surface mount LEDs, 4000 Kelvin. Damn it, where's my extra nice ones? I got my 4000 Kelvin LEDs, but you know, we want the other ones. Where did I put them? Maybe they're in another box. Okay, they're just other circuit boards. Here we go, ring light. Yeah, okay. This is what I was looking for. What else we got in here? Okay, arbitrary. So I was going to use one of these LED drivers. They're just like pre-module ones. But in the end, I found a very nice little DFN8 driver. So we're going to go that route. Don't think I really need to worry too much. We'll get the LEDs on. Yeah. Okay. I'm going to have to do this under the microscope with my current microscope light. I'm just going to go around and splotch on some solder paste and then stick it onto the heat plate. My nozzle's kind of clogged up there, so we're going to have to really squeeze out at first. There we go. You don't really need a lot of paste on these things. I see people just gob it down, and it's just like, you don't need that much. Of course, it's a pain in the backside when it won't just get off the... There we go. It's been difficult at the moment simply because of the fact that it's kind of clogged up inside, and so it just sort of comes out in little spits and spurts. Needs a bit of a flush out because I don't take care of my solder paste. I treat it like a third-class citizen. And you'll notice this time I actually made it so the lights go around sort of in a circular fashion rather than before. I just did them in parallel. Poor old creature was having aneurysm because of the way I did it before. I'm kind of hoping maybe though, being in a more circular arrangement, it might improve any sort of polarized light output effect. How's the wing? It's still crappy. I did the factory reset on the router, which I sort of suspected wouldn't do diddly squat, and sure enough, a couple of hours later it just drops dead on me. And then I go to contact him this afternoon, and I can't get a damn thing out of him. So I have to try again tomorrow. Essentially what I've got to do is get MBN or whoever these days manages those the line itself to do that, to do a test. Yeah, we're just going to splotch and blotch there. That's going to be a mess, this one. That's the DFN driver, so it's probably not a good thing for me to mess that up, but oh well. Yeah, that's not required. And yeah, for the actual switches, we're going to use these ones with the physical keyholes. Yep. Hi, Victor Young. So hopefully the connection won't drop tonight. I don't know what it was this morning. I don't know what was going on, but it was truly atrocious this morning. Like I was basically having dropouts every couple of minutes. So I went out to the junction box and I grabbed the had a look at the Scotch what do you call it? Scotch connectors, half expecting them to be flippity flip. Half expecting them to be broken off because they have been in the past. Okay, I'm just verifying something here just to... But they're all good. At least that I could see. The only thing I could possibly think of is maybe there are the arrestor blocks on there. Maybe one of the arrestor blocks is starting to get a bit dodgy. But I don't know, it doesn't really overall feel like it. Now hopefully I don't put one of these on backwards, although it still stumps me as to how the other board I did was working, even though I did put one of them on backwards. I didn't even change it around. It's just Yeah, something defied the laws of physics there. I thought I'd best not... Oh, flippin' heck, another one I just spat out. I figured I'd best not mess with whatever violation of universal properties was going on. Kind of easier for me to move the microscope than it is to move the... I really should have numbered these so that if I make a mistake, someone can go, "You botched up on number 12," or something like that, you know, rather than people saying, "Oh, you messed one up about 3 or 4 ago." And I'll be like, "Which one?" And they'll be like, 3 or 4 ago. And I'm like, "Oh, I don't know which one it is." Hey Phil, by the way, I got your email, Phil. Basically, I'm going to look at producing flat packs, not flat pack, app, what is it? An app image for Linux so that I don't have to deal with emails like what you sent. I've been meaning to, I just, like everything. I've got plenty of square to it, but I don't seem to have enough round to it. I am not going to be cooking in a pizza oven. I have a hot plate. I've got a very large hot plate that I use for other things, but then I went along and bought this small one. Again, I was getting too tired of screaming people, so I was like, well, I suppose I should do something with all the advertising money that they get me, which really isn't a lot. I think I make about 200 a month from everybody, which is pretty much nothing. Pays with the internet, I suppose. Oh god, no, don't. I'll never do a snap. Please. Hopefully the universe doesn't now turn around and force me into a situation where I do actually need to do a snap. And I have effed up these LEDs, I just realised. Because I was too busy talking to everybody. Alright, what I've done wrong is, you'll see I actually took the time to make sure these were keyed on the circuit board. But I didn't take the time just now to actually make sure I was following that key. I don't know how many I've put in wrong now. I should have had that over on this side, but oh well. When I was drawing the part in Eagle, I didn't really care enough, I suppose. The reason why I've got to have this resistor here, this is just a 0 ohm resistor, is to get the power from the outside of the ring to the inside. Because with these aluminium boards, you cannot put, you can't run traces through the board. Yeah, okay, these ones are backwards. Yeah, you can't run traces through the board, so if you need to jump from one side to the other, you have to do it using components. So welcome to why 0 ohm resistors are a thing. Zero ohm resistors essentially give you an additional layer on your circuit board. So your 2-layer board becomes a potential 4-layer board, and so on and so forth. Oh, yeah, another one still. Well, at least we detected it before we put it through the reflow. Well, Miles, I suppose they have really. It's just that it's not an overly clear marker. That's the only problem. Yeah, because they have knocked a literal corner out of it. Damn it. This here is a physically removed corner. So you can actually see it if you're looking for it, but it's not the easiest. Still, at least it is something on the top side rather than, a lot of them it's purely on the bottom side with an arrow printed on the underneath. And you sort of like, you don't really notice it until too late. And then you have to take it off to find out which. That said, you can actually usually, if it's a clear body LED, you can typically work out which way it is based on the dye connections that they have in there. Oh, come on, man, just roll over. That's it. Okay, so that's the LEDs done. And this is why I will not do these commercially. It's like there's no way you're going to get me to sit around here all day slowly putting those things on. Hell no. I'll get someone who's got a pick and place machine to do that for me, thank you very much. Okay, so these are my LED drivers. Oh no, that pin, is it right? I'm pretty sure I copied it correctly. And I think pin 1 was up there. Yep. Okay. And that resistor that's above it, that is the current limit resistor. Now for what I want to do, I needed 800 ohms, but I couldn't get 800 ohms of course. So instead I took the closest match that I could get, which is 806, and that's fine. There's no harm in having a little bit of a... Whoa, why do these look weird? You guys look weird. What the flip? Blue resistors? Did I order something I didn't mean to order? $806, 1%, 1/8 of a watt, 603. There's nothing special listed about these resistors, yet they're blue. Maybe it's because of the spec range, I don't know. That is very interesting. But I always use one. Yeah, most all metal film resistors these days are 1%. So there's nothing special there. It might be because it's in the next, what do you call it, division grade? What do they call it? I forget the E series. Like E96 as opposed to E48 or something like that. Or maybe it's just they want to be different. No, not high power reading. They're just standard 1/8 watt, which is pretty normal for a 603. Oh wow, Paul, you completely didn't get that. Damn. That's weird. In the... That doesn't even exist, the lying bastards. Oh well. In the PDF, when you're looking at these things, they say that they have a foot at the front left here, which is why I got a pad there. And it seems in production they do not have that foot. Now, also I've noticed that they do not protrude beyond the edge, so that's going to be interesting. Stop talking to measure them. No, they're 806 ohms, I already know that. Okay, I don't know that, but I can't. I've got no compelling reason to believe otherwise at this point, aside from the fact they've got a pretty colour. And if this thing goes up in a great ball of fire, then, well, that's all the more interesting for everybody. Yes, crystal balls. I don't have steel balls, I've got crystal balls. Hey Bunty. Yeah, we'll make a good video if it goes up in smoke. And isn't that what we all just want? No, mine don't resonate, mine spark. Hello 7805. It's been a long time since you and I have pointlessly danced. Okay, capacitors. We just need some 1 microfarads and some 100 nanofarads. Nothing special. On the input side though, we probably do need to have like 35 volt rated. 25 volt, that's not enough overhead. 50 volt is good, if it was silly. 1 microfarad, 50 volt. Do I have any higher bidders? 2.2 microfarad. Oh, hello, spider. What are you doing on my leg? What are you? You're an interesting little fellow. What's your name? No, don't crawl in my pants. Oh, you are being difficult. Come on. So I just got to get a spider off my leg. It's a bit of a weird one, so I'm just gonna have to coerce it to, there we go, see, it wasn't so bad. Yeah, and it's run off to find a new home. Okay, 1 microfarad, 50 volts. That's going to be on the input side. 35 volts would have been ample, but I'm just pulling out whatever's conveniently in my hand here. There we go. Oh, come on. Surely I've got a 35 volt, 100 nanofarad. No. Looks like it's 50 or bust. Now, no need to kill anything around here with fire. Spiders are perfectly welcome in this house. Now the only thing I'm worried about at the moment with this setup is that I may not have enough decoupling on the 785. They're usually a fairly stable voltage regulator, but if we start getting weird oscillations, I'll have to throw on a 10 microfarad or something like that. But it should be fairly stable as far as I can tell. So I'm just going through my pile of other parts that I normally use. Oh, here we go. Because that is the thing that is an advantage with the non-low dropout regulators such as these, is that they're very stable. Whereas when you're dealing with the low dropout regulators, you do have to be mindful of, if you've decoupled them appropriately. Otherwise they can start having some wild oscillations. As always, refer to the documentation if unsure. Hey Gamejoy, the Dumres. Alrighty, I think we're done. Oh wait, no, we've still got that one there. Now that there is going to be a 1206. Actually, that makes me think I've got another one of those to do too. I've got a pair of 1206 size 000. Here we go. Or did I? Yeah. Oh, actually, that's a 603. Whoops. Okay, this here, that's actually meant to be a bridge. As is this one. 1206 surface mount parts, they're fun. Because they're so large, you can do them without glasses even. And pinching the solder paste, they certainly will try. Okay, let's just settle the hot plate. Now we just need to get some voltage. A nice 240 voltiarts there. I will tell you this much, I do not trust these things very much. Okay, that was a bit of an idiot. I should have put it on a platform I could pick up. Okay, zoom in on that. There we go. That should give you guys a pretty good view. I'm not sure what I've got this temperature set to. 210, that should about do it. Okay, but now we just got to sit back and wait for the reflow action to happen. Zoom in a little more. Christian, no, this is just a heating plate. There's no control on this. The only slew rate control on this is just simply the thermal inertia of the plate itself. It is not a reflow oven. Not even remotely close. C4 missing. No, that's just willingly left off. Likewise R4. They were there simply if I wanted to, or I feel the need to later. So we just clocked into 100 Celsius now. Jim, it was a bit of trickery, but I can, with the Panasonic, you had to hold the zoom lever to the wide mode, then you had to press and hold the, I think it was like an HDR button on there, and then you had to press and hold another button, and then you had to sacrifice something. It was fun, but then it did do the changeover, and it brought up the menu option that allowed me to switch it to 60. Yes, to Dumres, I do have the USB-C meter boards here. They were the black ones that you can see. Okay, it looks like we're on the reflow now. Not 100% convinced it's properly done though. Okay, I'm going to turn off because obviously it's got enough heat. Ah, look at that. This is why sometimes you need more solder paste. Also, sometimes I want to have a slight vibration on the boards so that they can center in. We'll see how it goes. It was certainly a frustrating process when I used to do the manufacturing here, and even if you got your stencil right and all your conditions were right, you would still end up having to rework, maybe 10-20% of the boards that you did. It was inevitable. There was always something on each of the boards that had to be touched up. The lead right of R2 doesn't seem like it is that is correct. You're talking about this one. There's a reason for that, and that is that I had to route a trace through that area, and there was no way I could maintain the required clearances without pushing that LED up. To be fair, all of these LEDs, they are arranged by hand. I didn't use a script or anything to do it. I worked out the angle that they had to be, but beyond the angle, I just sort of placed them visually. Hey there, DXD from Malaysia. I've only ever been to Kuala Lumpur, so I haven't actually had a chance to explore Malaysia, sorry. So basically I just have to wait for this to cool off. If I try to take it off the plate now, it will likely misbehave. But I can see already that some of the flux is starting to brown up. Let's see if we can crank that fan up a bit. So hot plates are convenient, but yeah, they're definitely not a replacement for a proper reflow oven. Because if you have a proper reflow setup, what happens is as soon as you do the actual reflow point, where everything melts and goes, once that's done, you have to cool down the board as quickly as you can. And for me, what I used to do, because I didn't have any sort of active cooling system or whatever, it'd just be a case of I would be waiting on the outside of the oven, obviously, and I'd just pull the door open and then pull the tray out. I had to make sure I didn't do it too aggressively though, because otherwise then you just end up making all the parts come off the board. Okay, it's got to be getting close to being able to handle it now. Yeah, okay. It's good to go. It is definitely going to be hot to touch. Let's see what sort of rework we've got to do now. Oh, yeah. Holy hell, yeah. That's... I'm not surprised that needs to be reworked. That's fine. These big chunky parts did pretty good. They might have wanted a little bit more solder, but they're okay. Too much solder on that. That's okay. The LEDs probably could have had a little bit more solder on them to help them reorientate. So like you can see this one here, it didn't quite bring itself into alignment, nor did that one. Not a big issue, but it's just something to note. Interesting it didn't melt there. That's because that was elevated up in the air. But yeah, this driver here, that's definitely going to need a rework. So what we'll do is we'll use the micro pencil to first even up that solder, and then we'll hit it with the hot air and just get it to sort of, and a bit of flux, and get it to reseat itself. Obviously it's quite a bit more difficult to rework on these aluminium boards because of the fact that, well, they're aluminium, so they're going to eat up a lot of the thermal energy that you normally will be putting into the part. I think we're doing alright there though. But it will still need a reflow, but at least the arrangement of the solder is a bit better. My biggest concern is that I'm going to upset those LEDs. Wow, I cannot get that to budge in a hurry. I might put a protection over those LEDs. Like I said, I don't want them melting. So I'll just put some shielding over them. Yeah, Captain doesn't really... The trouble is, see, the Captain sits on top of it. Like, actually sits on the part. So as a consequence, when the Captain gets hot, it's kind of still like touching it with a hot part. probably degraded the LEDs a little bit. And that's a lot more heat than what I would even put into an SMC. Jesus Christ, that's hot still. Just going to put it in the cooler. Oh, that was still well over 60, based on how quickly it got through the gloves. Yeah, we will meter it, just to see. Hot things happen to be hot. It's a shocking revelation, I understand. But these feel cheap and nasty. This feels like something to get out of a dodgy Chinese product. Alrighty. Let's continuity test a few things. Checking. Let's see. 5 should be ground, but everything else should not. Okay. So 5. Let's see. 1, 2, 3, 4, 5. Okay. Okay, nothing short of this, that's good. This should be 806, yeah, 805, so that's good. Alright, well, we haven't got to the point of programming the PWM driver. And to be honest, I'm not sure how this is going to behave, but yeah, we'll give it a go. Do I got enough? Yeah, there should be enough there. Like I said, these could have done with more solder, but given that this is only powering basically the microcontroller and I think this? No, it doesn't even power oh yeah, it does, yeah, 5 volts into this. So you're only talking like 10 milliamps at the most. So we're not too worried about that. So at this point, essentially, now I have to plug and pray. Let's check that we've got the right voltage coming out of this thing. I know, I'm just deferring the obvious. 24 volts with a bit extra. Stephen, the main problem is that I've got a 20 volt drop. Nothing. Shit. Alright. Fantastic. Have I got everything backwards maybe? Put the blue thing on wrong. Pfft. Yeah. Pessimist. This is the only trouble I do have with using. Let's see. Is anything going on smoke? Here comes the troubleshooting time now. Yeah, that's kind of weird. So it's trying to drive it. The driver is trying to drive, but it's not getting anything. Maybe I've miscalculated my resistance. Looks like I'm fairly sure it was 806 I needed. Maybe it was 80 I needed. Doesn't make sense though. But at 37 volts, that kind of makes me feel like maybe I've got something backwards. So these are all the cathode runs. Even if one of the LEDs was around the wrong way, to have every chain with one of them the wrong way, it seems a little bit weird. Well, the first thing we can do is we can actually test the individual chains. So what we'll do is... where are you? Just turn that off momentarily. We're going to steal our probe points. This is a little bit naughty. So 1, 2, 3, 4, 5, 6, 7. Oh, that's right. Yeah, we're running seven LEDs per unit. Okay. We're going to set the current down to quite a bit less than what it is now. $80 milliamp will be fine. Okay. So if I get this right, else it's going to be a flashbang. Well, it's still going to be a flashbang no matter what. Oh, fuck. Why did I look? Yep. Well, I think it's safe to say that, you know, it is doing what it's supposed to. Yep, they're all working. Okay, so there's nothing wrong with the LEDs. So it makes me think that I may have miscalculated the driver feedback LED resistor. So now we get to the point where we go to look at the data sheet and see what I miscalculated so horribly. Now, if I can remember what this damn chip was again. Maybe I damaged the chip, you know, that's the other possibility. Although, like I said, it is driving at 37 volts, so it kind of feels like it's not actually doing a ground return, but it's just weird. It's just very weird. Damn it, where's my... yeah. Okay, so this is a on semi. Geez, man, why don't they have the part name just listed there instead? I'm going to have to dig through. I would say it might have something to do with the enable, but then, like I said, I would be not expecting anything if it... Anyway, let me just... I'm just going to go in and have a look at my purchase history. No, it's only a feedback resistor. It's just used for determining what the current should be. It's not actually a current pass resistor. Stream tracking. Some assembly required, most certainly. Okay. Alright, so this is what it is. 700 milliamp quad channels, so that's 700 milliamp collectively, not 700 minute per channel. We only end up using at the most 150 per channel. Did I get everything just backwards? Did I design this in a terrible way? No, I think I got that right. Yeah, because this is the one here, this is the top view, and I've got my LED returns here. My R set is not actually reset, that's the current set. So what I could try to do is just simply pull this line straight up. And yeah, like they've got 768 there, so 800 can't be. Yeah, and 5 is ground, so that's fine. What I might do is short this enable PWM pin, this one here, and take it up to VN. So basically if I just bridge these two, oh wait, not VN. Yeah, VN. So if I bridge those two, it should come to life. Oh, damn it. Looks like momentarily I have to re-establish the old microscope light. Let's see, current 400 on. So in theory, those bottom two. Oh, not bottom two. Wait, yep, bottom two. Enable and PWM. What am I doing with the enable line? Let me see. Did I completely just forget to connect it or something? Okay, so my enable line snakes in through those, goes up to here. So yeah, I should just, if I put a blob of solder on there, that should do the trick. 24 volts is coming out of the plug pack, which is kind of weird why I'm seeing 37. That's definitely weird. Anyway, solder blob to test. But if it was 37 volts legitimately, you'd definitely still get some brightness. We did measure the plug pack, remember? That was one of the first things I did. Yeah, the chip's rated to 25. It does have a voltage over that yet more. Alright, we're just going to try it with that bridge and see what happens. Nothing. What the fuckity fuck? Alright. Maybe my 7805 is no good. Maybe I've... Am I actually producing 5 volts out? Yep, 5 volts. $24 volts. Alright, what's going on there? Oh, I think maybe that resistor's not touching properly. Maybe there's... the solder isn't right. Yeah, maybe that is not connected down properly, so we'll give that some more solder and see what happens. It could be insulated off the base there by any sort of flux or something. Like I said, this is why hot plates are not the same as reflows. Because usually what happens is that they burn off the flux before it really gets a chance to heat up the components. So the components don't really enjoy the benefits of the flux until, anyway. So the flux burns off, the solder then melts, but it's too late. Yeah, that's what it was. Ah, it's a Christmas decoration. Holy crap, that's bright. You're alright. Yeah, no ground return. Well, actually, no, it was a ground return. What was happening is that, actually, maybe this here is actually the 24 volts. See, it comes out of the plug pack, 24 volts. But maybe what I was seeing, because I measured this side, it was just pushing the voltage up as high as it could. That still doesn't make sense though, because this is not a booster. It's just simply a linear regulator in a way, I think. All we know is it wasn't working, and now it is. So, happy days. So that's the first stage sorted out. We know we've got a nice steady voltage, and now we've got to work out how to program this damn thing. That's going to be fun. Even more fun is the fact that I got the orientation of these programming pins the wrong bloody way around. Josh, I'm going to leave it up to people to put a diffuser ring on it if they want. I ended up using a discarded LCD panel. This is LCD panel, but the only thing is it seems like you need to be like 5mm or so above it. So if you get too close, it doesn't have any effect, but about 5mm away, it does a good job. Remove bridge. Oh, right, yeah. Yeah, okay, I suppose we better do that. Okay, bridge is gone. So now comes the fun part of programming it. It's fun because I have never programmed the 212 or any of these new series ones before. And B, it's PWMing. Now, of course, these AVRs do have pretty good support for PWM with their timer. They got 16-bit timers in them. Yeah, they do a good job. But chances are I'll just bit bash it because I'm a Neanderthal, or how the hell you pronounce that. I'm a cave dweller, alright. And bit bashing is like, it's just the way I love my electronics. I like to bit bash them. Yep, I've reinvented the wheel with a square edge. That's so that you don't need a parking brake, you just put it on the square edge and it's not going to go anywhere. By the way, anyone who knows that I had that video of my car with the where I used a screwdriver to fix up the automatic gearbox selector, well, that no longer applies now. I took the car in for service today and I didn't ask for it, but they fixed it up. And as an extra bonus, I couldn't start the car when I went to pick it up. They gave me the keys, let me get in the car, and the engine didn't turn over. All the lights, everything came up, but the engine didn't turn over. Oh, there's a bug. Anyway, it was a bit of a amusing point for them, because what I had on that car, being a Falcon BA, along with many other Falcons of that era, Fords of that era, is that the ignition barrel, there's the way they fire off the starter is they've got like a couple of ball bearings on the bottom that connects a trace together. Anyway, it wears out over time, and mine was wearing out quite badly, but I was able to still pull it out and wiggle it, and it did the job. And I think it frustrated them too much today, and so they ended up just simply putting a switch in the car, a push button. So now I turn the key to the usual sort of place, for everything on, and then I hit the push button and it fires up the engine. But they let me sit in the car park for a couple of minutes, panicking, thinking, what the hell's going on? Because it was after 5 o'clock too. And then they came out, the owner came out and says, you want to know how to start your car? And I was like, God damn it, yes. Fortunately I know them quite well, so it was all fun and games. Alright, so I'm going to connect a programming lead to this, and the real fun for tonight is going to commence. I need a female to female cable. Yeah, a female to female back to back, that would be good. What have I got over here? Please tell me you're a double female. Alright. But of course the unfortunate thing is I actually have to reconfigure the cabling. Crap. Damn it. Oh, you know what? I can actually get away with this a different way. No, I can't. Oh, there's no win for me anywhere. The problem I have here is that, you know what, it's just going to be easy for me to get one of the cables I don't care about. It will be one of these. And I will wire it up how it needs to be wired up. And then I can just put a butt-to-butt connector on there. That'll be fine. Or just simply take this one off and, yeah. It's all good. Yeah, it's not going to matter because the UPDI is in the middle, as you say. Whereas, see, with my programmers, oh, it's micro time. Okay, everybody, sit tight for a couple of minutes. I've got to go give Micro his insulin injection, and I'll be back for the intermission. And I'll be really cruel. Be right back. So did an advert play at all? Because YouTube told me that. It said you should insert an ad now. And I'm like, yeah, why not? Drain you guys of some money. Yeah, at least you might actually have some purpose here. Damn it. I'm not going to use an RJ11 or 12. Gee whiz, what do you think, I'm sophisticated or something? You people have a very deluded sense of my level of care about doing things properly. Very deluded sense. Ah, damn it. I had Harold's awesome, what do you call it, pliers here today, and I've misplaced them. So now I'm going to have to dodge this. Okay, yeah, we got lucky. Actually broke it off at the 3 mark rather than 4. Well, thank God, I actually did put them on at 0.1 centers. I wasn't sure if they were 0.1 centers because I just eyeballed it. Yeah, maybe it'd be easier if I was going to do it like this, but given that it's insulated, I can probably use straight headers. Yes, Tom, it is going to be a variable light. That's why we have the microcontroller on there. What are these? Oh, this is some cheap, nasty, nickel-plated, terrible quality stuff. Perfect. Yeah. This is supremely dodgy quality stuff. Kind of tempted to put great big mounds of solder there and then have them join into that, but I don't think it will reach, but we'll see. There's Pedro in here. Hey, Pedro. Bismillah, yeah, they are for the variable brightness. You know what, we might actually be able to do my little bodgy plan. Come on. Bodgy for the Aussie. Bodgy Aussie. Yep, Dodgy Brothers Engineering coming right at you. Now, because the best thing here is that it's now going to melt. As I said, it's going to melt. I should have done all of them at the same time. Okay, let's do that again. Let's build it up, build it up. Hey there, Arula. I sincerely do not recommend taking this course of action for your own projects. I'm only doing this because I'm lazy and spiteful. I don't know why spite comes into it, but I thought I'd just throw that in there for good effect. Now, for some of you might be wondering, why the hell don't I just let it rest onto the circuit board? Well, the problem is that this circuit board is essentially a sheet of metal underneath that conformal coat, or the mask. So should it by some crazy reason touch or get through that layer, then there'll be sparks and excitement for all. So instead what I'm doing is deliberately raising it up like that. It looks silly, it is silly, it's weak physically, but it shouldn't go sparky spark. Not that it would really spark that much. I mean, come on, 5 volts, a couple of milliamps, ooh, big sparks. But you know, I don't want to botch up things I don't have to botch up. I already botch up enough as it is on my own. I don't need it to be extra botchy. And of course, it's at this exciting moment that I realise I actually didn't need to do any of that because I've got the frickin' cable and I can just... Oh man, this is why when you're working on things, having distractions is such a bad thing. So I was heading for doing this the proper way, right up until that alarm went off to tell me that I need to go and give Micro his insulin. And because of that alarm, I forgot that this is what I was doing, and I came back and just decided I was doing the headers again, but I'm not. Anyway. But yeah, it's a good example of why interruptions can be very bad. Not, yeah, obviously I'm going to do Micro's insulin, but yeah, just in the office, random people walking in, chit-chatting to you. It's actually surprisingly hard to split these cables when you're wearing gloves. When you just got your fingernails, it's dead easy to split them, but with gloves, not so. Okay, so what we'll do is we'll flip it around this way and then take the ground above. Really, it doesn't matter, it's all going to be the same. I'm just going to splice them all open. Solder out of Captain tape? Where the hell did you think I got solder with Captain tape? What? Yeah, this is going to be silly now. Very silly. Yeah. But I'm going to go with it. This is going to be a, what do they call those machines that are pointless? A Rubberg machine or something like that? Goldberg machine? Rue Goldberg? I don't know. The things that do, do a lot of things but do nothing. Oh wait, that sounds like me on a normal day. Okay, we got a cold joint on that middle one. We put a piece of tape down and melted it and turned to solder. What? I'm almost certain I didn't. Oh no! That it was just me. I put a strip of flux across it. That's what you saw. It was just a bit of flux. Interesting that it showed up more as Captain tape to you. And Mohammed, Alright. Well, at least we don't have cold joins anymore. Instead now they're just cool. And the hilarious thing is I actually have to do the opposite on this side. I have to take off. My god, is there no end to my life struggles? Yep, Phil, bit banging time. It's the best kind. Okay. The first thing I'm going to have to do is see if this even is talking to the computer before we even get started. Well, it hasn't killed it, so that's a good start. History, grep, MCU. Okay, this is 212. And no, e-message. Oh, I thought I fixed that. USB 2. Okay, apparently it's not seeing that. Interesting. Oh, I know why. There's no such thing as a USAT device. Oh, whoops. Oh, UART, Paul, UART. Initialization failed. Okay, so UPDI initialization failed, but it did actually at least... Yeah. It's on USB 2. Okay, why would the ping fail? Maybe, I was going to say maybe we got a problem with the supply here. I'll touch up those connections, you never know, just in case, but I doubt it. Check the connections, then we'll check that we're actually getting what we're expecting, you know, the usual sort of crap. It could be that the 7805 is actually bullying the 3 volts, but in saying that, so the 5 volts rather, in saying that, it seems a little weird. Is my 5 volt even in the right place? That kind of feels funny where it is. Yeah, it's pin 1. Ground should be on the other one. Yep. Alright, we'll plug it in, check our voltages. 3x, no. The reason why it's going to be a lot harder, we need to do it this way because we're going to be doing multiple reflashes as we develop the software. Okay, we're at 3.3, so that's not being clobbered. Yeah, I was thinking that maybe that would get clobbered, but it's not. Do I have to have a pull-up on that UPDI? I keep forgetting. As far as I know though, the pull-up should be being done over here by this. So I don't believe anything else is required. Yeah, I'm a little stumped by that. Yeah. I'm just going to check the programmer. The way I can do that is I'll just get another... I've got that prototyping board I did the other day and see if it responds. And this is it. Yeah, that's it there. So we'll just use this female to female again. And we've still got a problem there. Alright. Interesting. There's a problem with my programmer. That's also the same. What the hell's going on here? That's very weird. It's not working at all. Like I said, we tested this the other day. That was working. This is exactly the combination that we had. These are in fact, the very two devices that we had. No, well, the USB cable seems fine. It is detecting it. It's communicating with the programming. It's not communicating this. That's the problem. Because it finds the programmer. Now, Tom, this is a completely different set of devices. This was a known working pair a couple of days ago, and I haven't touched it since. So this is my reference pair. So I know this works. So if I can't make this work, then it's got nothing to do with the physical hardware. It's got something to do elsewhere, up the chain. Ah, boy. Again, Stephen, it doesn't matter because this here is a known setup. This setup works. This setup, we did it on video the other day. it works. We know it works. We used it before. So it's got nothing to do with anything that we've done tonight. And I've only just pulled this out simply because we couldn't get that to work. Operation failed with PyMyCU, blah blah blah. UPDI initialization failed. About as useless as a chocolate teapot, mate. Okay, so alright, so that one's on now on 3, so let's try that. Okay, exactly as I was saying, this hardware works fine. It's on USB 3 for this, and it works. That bit works. So now what we'll do is we know this works, we know this works, so we now verify that this works by plugging this in using the back-to-back cable. Plugging it in correctly on this side, plugging it in here, okay, so that one's now on 3 as well. It's ping device, it works. Okay, so we know that programmer also works. So now we go to the next step and we plug this one in and see if we can do the same thing. Plugged in, and naturally it fucking works. Maybe it was just a bit of dirty junk on there. Alright, we're on our way now. Now we've got a program. Now we've got to actually write software. What was I thinking? Writing software on a live stream? Yeah, dumbest thing ever. Especially considering that I don't even... Yeah. So PA3 is our line that we want to PWM. So I think the simplest thing we can do here is just simply make it clock out a square wave. That's all we've got to do. Square wave, that'll give us 50% PWM and hopefully half brightness. And we'll work our way up from that. And of course, naturally, I cannot remember a goddamn thing about what I'm doing with my programming here. You know what? It's so bad, my memory for this, that I'm going to actually have to copy from some simple project. Let me find the simplest little project I might have somewhere. Naturally, of course, they're all complicated projects. Blink. Yeah, Blink looks promising, doesn't it? Put switch, that will be unfortunately USB one. Jitterbug. Jitterbug is actually one that might work. Hey, what the? Oh, great, keyboard doesn't work now? What the frick? Cap lock's on. That was weird. Oh boy, this is some old stuff. This is not a simple project, but it's going to give me some fundamentals, so I'm fine with that. We're not going to be interrupt driven. We're not going to have a... Yeah. Okay. Let's see. What do I want? PA3. Okay. Let's see. Pin A. No. To be fair, I don't know if the XOR trick works in these ones, but we'll find out. Let's see, AVR, GCC. Weird, it doesn't recognize DDRA. Please tell me that the GCC, AVR GCC actually knows the tiny 212. I'll be in big trouble if it doesn't. Oh yeah, it says device type not found, not defined. Wonder what it is actually listed then as. Alright, I'm gonna have to find out. Okay, AVR X Mega what? Okay, so it is AT-Tiny 212. MCU. AVR X Mega 3. That doesn't really make a lot of sense. Nope, it's not that. Yeah, must be missing something else. Maybe it's a header file at once. But then again, it is complaining that So device type not defined. God, I hate this green writing. It's impossible to read it. T212 might be worth trying, yeah. No. Okay, actually, we've got a thing here. Locate specs. Too tiny. It does have it there. Specs tiny 212. Okay, gvim. Let's have a look at what it actually has in that file. Okay, edit. I'll just increase the font a bit because I'm blind. Well, it's definitely there. Hey, Ratmole. So we do have the correct chip. It's io.h that's complaining. So maybe we just ditch that for the moment. Because to be fair, that io.h is prehistoric. Okay, and then we're just gonna come up with more weird. I don't know why. What's this type 36 engaged crap? Right, PA. I don't get it. Have they changed the way that they specify? Because that's pretty standard nomenclature for these chips. Gabor, yes, you are correct. Pin A is technically for input, but you see, when you do this, when you assert, actually, and that is actually wrong, I think. No, that's correct. When you assert a set bit to the pin, like pin A, it toggles the output. It's a bit of a it's a little trick. That you can try it on one of your own AVRs. If you do that, it will toggle the pin. So rather than you having to say set high, set low, or whatever, you just do the XOR trick with the bit. It toggles it. Anyway, regardless of that, it's not actually finding any of the definitions. Like, it doesn't understand what DDRA is, it doesn't understand PA3, and nothing. So I've got to find an example. Sample ATtiny 212 C code. It actually doesn't matter what bit it is. It could be random. Thing is, it keeps flipping it. That's what. It's a very handy little one cycle trick. Look it up. Look it up and learn. So what is it? Atmel AVR pin toggle trick. Or was it? No, there you are. There it is, there. Maybe they don't do it anymore, whatever, but yeah, this is basically what it is. So I was actually wrong. It's not XOR, it's OR. I was wrong on that, but yeah, you can do it by accessing pin rather than port. Need delay after the toggle to see it change. You actually don't really, because we're only PWMing to produce and infect a reduced voltage, so it doesn't really matter what clock cycle it's going at, so it'll just go as fast as it can. So say if it's 1 megahertz, we're going to do probably around about 125 kilohertz PWMing, 50%. We don't really need a delay. Regardless, we still do not have DDRA not found. This is starting to tick me off. Yeah, I'm bit banging the PWM. Just for now. I'll look at doing it properly through the clock later. Because yeah, I mean technically, you know, it is better to just set the TCNT, I think it was, clock count trip. Data sheet. Usually these guys will have some samples of how they want it. Okay, so they are referring to PA, PB, all that sort of jazz there. So yeah, PA3. I must be doing something wrong in my compiling flags somewhere. I've got AVR.io.h in there, and that's actually the one complaining that it can't find anything. And then I took it out, so that complaint went away, but of course it still didn't pick up the definitions. So maybe AVR GCC actually has them under a different header now. And I was kind of hoping I would find an example in here, because usually they like have a bit of assembly plus C code. But they're not giving me, they're giving me stuff all. I prefer the older data sheets where they gave you examples. Alright. So yeah, if I put in there, include AVR, it complains about it. So, warning, device type not found. And of course it still errors. So maybe we can find it in amongst this lot. Okay, I would say that IOTN, we're looking for 212. I bet you there's no IOTN 212. In fact, I can't see any of the new tinies in there. So 2313 I know, 2425, blah blah blah. Yeah, we are missing the definitions in here. What? I saw that, Teresa. I mean, I know these are moderately new parts, but they're not that new. Kotas, AVRX Mega 3. Yeah, we tried that, but it, or you saying that they're included as part of the AVRX Mega 3. But if that's the case, it still shouldn't be complaining in... This should still not be complaining. That's the problem. And... I can't even see an X Mega 3 in that list. Okay, what version are we? 540. It's like that came out July 2019 with the support for it. Shifts the AVR V2, which is this, but in dog. Okay. So it looks like we have to have patches. When was this? This was 3 years ago. Come on. Now this is Windows crap. What the hell? AVR GCC 12? And I'm running 5 point something. God damn, you Ubuntu slack ass bastards. How, version 5.4. How bloody old is that? Oh wait, they're talking to AVR dude, aren't they? And yeah, we're up to version 12 here. Okay, do they have a Ubuntu PPA or something? Fucking hell. Sorry. Anyway, so that's why it's not compiling, because this is a very, very old version. AVR GCC or Ubuntu latest. Yeah, 5.4. So, oh, that's on that. So packages. So I've got Jamie. Phil, unfortunately, it doesn't work because it already is the layout. The problem is, see, look, I'll show you, just so you can feel like I listen to you. Anyway, it's we'll just update. And this will upgrade everything. It'll also probably kill my streaming rate. Great, we've got a new kernel. Oh, that's going to be fun. Next time I reboot, it's going to be a sad day. Oh, I love this kind of attitude, you know. Why can't you just use 5.0? Well, probably because the devices aren't supported. Okay, so that's done. And now if we go AVR, and yeah, 5.0, 4.0. So yeah, that the problem is that Ubuntu only has this version as its current. So we essentially need to remove this and then install this other one here. So sudo apt remove purge. What do you mean you can't see it? Yes. Okay. Do not expand into... I must have a... Oh no, there it goes. Right. Yeah, there goes the X Mega stuff. It's a 2 series chip. Oh, this is gonna suck balls. This is the big reason I did move to Ubuntu and similar well-maintained, well-packaged systems, is so I wouldn't have to deal with this kind of crap. But I suppose when the package maintainer doesn't bother updating, then I'm kind of up the creek anyway. Okay, that's nicer. Okay, so we can start with that. Still not right. But at least it's not complaining about the fact that it is not... Yeah, it's not complaining about the I.O. Assuming I've still got it there. Yeah, okay, so I've got the AVR I.O. in there, and it's not complaining about it now. So we've solved one problem. DDRA undeclared. So I'm guessing I've got to include another header somehow where it gets defined. It doesn't matter whether it's port A or pin A. The point is here, it's not detecting anything in the RSAs like DDRA, PA3, pin A. None of those things are being detected, which means I'm missing all of the pin specification or headers or definitions for this chip. Xmega.h, maybe. Yeah. Should be in device specified IO.h. Yeah, that's the thing. You see, this should just work. And I think one of the things that you have to learn over time is that sometimes when you start getting this sort of crap happening, it's probably because of something really simple as opposed to having to go through and manually mash the hell out of everything to make it work. So what we're going to do is we're going to have a look in that folder. Have a look in the includes. Yeah, maybe not that one. Okay. Well, a lot of this stuff should actually legitimately just work on the basis of the fact that, you know, they are these days mostly handling noobs. Like, it just works when I use a Series 1 chip and program it and stuff like that. It's simply because of the fact that the Series 1 software does not support the 212s or the new types. So we've got to find out what we're missing here. So you can see here, like, okay, this file always includes the following files. So it includes the port pin definitions. Unfortunately, there's no repo for this, it seems. Header file includes appropriate I/O definitions for the devices specified with the MMCU, which is what we have done. Command line switches it up, averting the appropriate file. It should never be included directly. So this is what I mean. This is why I'm saying, you know, you don't want to go mash things too much because it should work properly. Let's see. AVR device defined directly within the AVR common. Blah blah blah. Most details. Okay, so what I might do is look for the 212 header file, and then from that we might be able to see what it wants. It must be including the header file with correctly, because otherwise we would get a complaint up here saying it can't find that header file, and it's not doing that. No. No. There we go. And we found it. And now we will find out what it is actually expecting for its pin port namings. Here we go. Probably GPIOs maybe. Let's look for DDR. There's no DDR in there. Oh yeah, there is. I think they've changed the way they do all this. Yeah, there's no DDRA. Okay, there is a PA3. And Jim, you're also about 30 seconds behind where I was. Okay, interesting. Okay, so the GPIOs are deprecated, so I can't use them. Yeah, Miles, it feels that way, doesn't it? Because, yeah, we've... For how many years have we been using things like DDR and pin and port and things like that, and now suddenly we've got God only knows. To be fair, it could be because you can actually shift the pins around now. I think that might be why they can't just go with a simple thing. Hey Raj. Okay, Jim's just... sorry, not Jim. Arnold's just linked something. And I can't seem to... Let's see, copy link address. Paste. Oh, here we go. No. 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 Okay, what am I looking for in this thread? Because so far it's not giving me... Yeah, maybe that wasn't meant for me. That link is no good. It doesn't tell me anything. At least nothing. We did try PA3. See? PA3. Oh, you mean what to look for? Yeah, I did try that, and it does refer to it indirectly. Asynchronous event from PA3. I kind of get the feeling, though, that things like DDR, PA, and all that sort of stuff may be actually defined in another header. And this is just more the specific mapping for this particular chip. Port pins.h, yeah, that's probably a more viable one. Yeah, okay, here we go. The question is, why don't these show up? And see, it even says here, include AVR IO instead of this file. Oh, wait, these are port 1, 2, 3, 4, 5, 6. These, port B. But these are generic as well. Define port XN and PXN for all possible port pins. No. Okay, no, that's right. If defined PA, not define port A, define port A, PA. I don't get it. Yeah. Yeah, 3x, that's a very effective way of doing it. I feel like I'm genuinely just missing something blatant here. Okay, let's go back to Google because Google, what the simple AT-Tiny 212 C program. Oops, double click. You better have some source code. Son of a gun. Wait, what's this? Oh god, it's Arduino. God help me. Okay, see if we can work this out. No, they're sketches, aren't they? Yeah, file download. Oh, good god, RAR files? Come on, people. Yeah, these aren't C programs. Yeah, the new Tinies, they're the second generation chips now. But like I said, I really am surprised that surely they haven't butchered everything of the past. This is old stuff. Yeah, this is very old. Okay, what do we got here though? PV1 to port B1. No. Come on, man. It's like nobody's written a simple goddamn program for the Tiny. Tiny 85. That one I already knows, so that's not going to help. Arduino can go sucker. Yeah. Okay, we've got a Russian site. Let's see if they lob something at me. Yeah, yeah, yeah. It'd be nice to get started with this because, you know, these chips have got a lot of really neat packages in them. And yet again, we do not have any code. Like I said, please, someone try find me an 18 Tiny second generation sample C code to turn a pin on. Oh, well, here we go. Maybe this will be it. Okay, what have we got? They got AVR IO, util delay, that's irrelevant. They got port B. What the they're using god awful. Have they really done this to it now? Port B dot direction. That's got to be Arduino, surely. Because it's kind of like behaving object-orientated-ish. Yeah, that's what I was thinking. Hey Warren. Yeah, we're just losing our frickin' head here. Too tiny for simple C program. Now this is just people talking about the actual programmer, which we've already solved. Thank goodness for that, at least. Start at Melcom. Might have a look at that in a little bit. What? I'm doing that. That's it. I think I'm going to just throw this all in the bin. It'll be something blatantly stupid that I'm missing, either a flag or a header or something, and it'll just make everything all of a sudden work properly. Okay, this looks okay. Now this is 4585. Yeah, so yeah, this sort of code here is what we already have done over and over. So this is first generation stuff, or Gen 1 I should rather say, as opposed to Gen 0. And these chips that I've got now are Gen 2, and so what? Oh, stupid adverts. See, again, getting started in 1 and 0 series. We are sample 2 series 80 tiny 2 program. Sad we're actually having to resort to looking at pictures. Ah, that's a 1 series. That's a Russian site. They do seem to like this whole port in out crap. Like this. So they've gone for the whole object orientated tilt. Definitely doesn't like pin A. It's interesting that it says, do you mean pin O? Yeah, I might have to just wrap this up for tonight and go upstairs, relax a little bit. It might come through to me. Microchip Note DS. Okay. Copy. I might have an epiphany or I might have an aneurysm, I'm not sure which. Yeah, cheating bastards. So we've got AVR IO, standard lib. That's weird that they've got this here. It's very strange that they've got this localized headers stuff. Everything seems to be this whole object-orientated style. Honestly, it's one of the most fundamental things you do when you're learning. Your hello world equivalent is making a port output go on and off, on and off. Unfortunately, no, the 1 series won't help. We're after the 2 series. That's the problem we're encountering, is that we don't have an example. We don't have a Rosetta Stone, as it were, for how to... Unfortunately, this is just too complicated, and they've gone and wrapped a lot of stuff up. I like how they say getting started. It's like, yeah, that's really getting started. Yeah. But even still, they, by the look of the include files that I saw, they should still be redefining them. So if I put in PA3, then it remaps it. Port set pin do... No, that's Arduino stuff, by the looks of it. Because I know they do have pin remapping as a feature now. But like, why can't I even get this? Yeah, Jimbo, that's Arduino stuff. I don't think that will work. So like that. I'll tell you, if it does work, I'm going to spew, because it means they've really killed the purity. Oh god. Implicit declaration, yeah. That's what I was thinking would come up. Yeah, that's right, for virtual pins or pin remapping. Yeah. But even still, you should be able to access the pins, yeah, the specific hardware pins directly. Yeah, I think that's a problem, Jimbo, is that they're sort of using Arduino as the de facto thing now, and that's what's pissing me off. Because yeah, ultimately you should be able to just do something like this. Yeah, you should be able to just do this and it will blink, or you know, even if you got to do like delay, MS, yeah, we'll do 10, actually 1. So... compiler optimization is disabled. Whoops. Okay, that's fine. It's not that is relevant anyway. Warning, FCPU not defined. That's fine. I don't know how fast this thing runs. Oh, that's classic. FCPU redefined. And yet it tells me warning, FCPU not defined. That's because it needs to be up here prior to the inclusion of the headers. Yeah, that calmed it down. As far as being moved to util delay, okay, we're getting somewhere. Yeah. Alright, let's try something daft like Pinot. So DDR O. So this maybe is how they prefer to directly talk to it. No. DDO? What is DDO? Okay, so the only thing we don't have here is PO3. Hey Jason. Should I be using port A? Oh, wait a second. Let's just try something here. Port AO. Wait, what am I after? PO, PO. Yeah, that doesn't make any sense. God damn it. All we need to do is get one little piece to fall into place and everything else will. L value requires left. Okay, so that's not going to work. Ah, crap in a cracker. Trouble is, Jim is going to be making it the damn Arduino code as far as I can tell, instead of C. No, I'm fairly sure I'm going to have to just close up for tonight because it is almost midnight and go have my epiphany upstairs because quite frankly I'm just spinning my wheels here and it's wasting everybody's time and everybody's getting frustrated. I mean, yay, we got the ring working, so that's good, but this crap is problematic. So I think that's it. We've been here for 2.5 hours. It's time to take a walk off. IoT and 2 uses structures as well. Yeah, so I've got to go and find out what the structures we're going to have to use are. So I don't know whether it's... If I could run C tags on the... if I could run C tags on that folder, well, maybe I should just do that. C tags. Let's see, home, PLE, downloads, include. What? Oh, right, downloads, AVR, include AVR, right. Okay. Found, eh? Not found. Wow, that sucks. Yep. I'm out of here. Thanks for tolerating it. Like I said, at least we know it actually runs. Now we just got to do better. I'll find out what's going on, and I'll come back to you tomorrow and let you know. Thanks all. I'll see you later.